The following presentation is for NEXIO's BAT-EMC software. We will be exploring radiated emissions in accordance with the CISPR standard. Let's first look at a project that is already open within NEXIO's BAT-EMC. If we were to look in this column, you can see that there are other aspects of this project. We will just focus on the radiated emissions test. In this example, we already ran a test. Now, what I would like to show is that in a typical lab, you can run a test and then say, okay, well, I would like to investigate further. For example, let's add a ferrite. I will duplicate this test. I can change the name of the test to make it simple. Added ferrite. And maybe I could say to power cable as an example. Let's select OK to update the name up here. Let's look at a subrange. If I open up this subrange, you can see that under the frequencies tab, all the right parameters are chosen: start and stop frequency, the setup that was required so that I can choose the right equipment, the polarity, distance, and so on. By doing separate subranges for vertical and horizontal, that means we have individual graphs. Some customers would like horizontal and vertical data to just appear on one graph. That is also possible. Under the settings tab, you can see that the receiver is chosen. These parameters reflect what is required in the standard. If I look at the procedure, we have different options. We could do a simple pre-scan, and you can see there is no mention of an antenna or turntable. This would be like for the mill standard. In our case, this is CISPR, and I will use the advanced pre-scan option to command the turntable and antenna mast. Different customers have different algorithms. The standard is not so detailed as far as how one does the maximization. In this instance, the request is to do a 1 to 4 meter vertical movement on the antenna mast, making 1 meter steps. However, for the turntable, it will move 0 to 360 degrees in azimuth. I will select OK. Now we can look at another item. Let's look at an ordinary suspect. There is nothing exotic here. Just to compare to the limit line, apply an offset, and it will capture all the peaks, and there is no additional filtering. With advanced suspects, we have more power. Now we can look at advanced suspects. If I choose Edit and click on the script, you can see that these parameters up above were set in order to generate this script. And on the first pass filter, we're asking a 6 dB deviation above the noise floor. That way we're not picking peaks out of the noise floor. Typically labs want to choose the 10 highest peaks, but we're only choosing 3 so that we can be faster in the simulation mode. The limit offset is -6, which is typical, and when we analyze these peaks, we send them to a table called suspects so that we can run the final test later. We'll select cancel. Let's look at the final test procedure. The final test procedure can be complex like you see here, or it could also be a simple one. For example, if I chose that, it would only do a remeasurement. It wouldn't do any further maximization. In our case, we want to do further maximization, and the routine here is to go to the original height and angle, do a full search across the azimuth and height to find the maximum peak. It will then center on that measurement and determine if there's any frequency drift. Then it will perform the final measurement. The measurement time is set up here as a variable. CISPR states that for unsteady disturbances, which implies also uncharacterized disturbances, they request 15 seconds. So that's why that is set there. Then we calculate the margins and we produce our own tables. This allows the user to define column names as well as the column order. So this is all the information that needs to be entered for that subrange. We have the other subranges, and you can see that for above 1 gigahertz it's going to be slightly different in the procedure. Why? Because we're going to be grabbing peak data and CISPR average data. Below 1 gigahertz, obviously, it's only the quasi-peak for the final. Next, I will do the test in simulation mode. And as you can see, we have both limit lines for above 1 gigahertz, peak and average, and then below for the quasi-peak. I can start the test. It's going to ask me if I want to stay in simulation mode, and I do. The block diagram appears. This is to verify the resources are correct, and if there was an opportunity to change resources, in this example there's more than one receiver, we could have done it that way. Now I will select OK in order to start the test, and you can see that in simulation mode measurements are being done. Obviously this is not as accurate as a typical emissions test. These are just simulated peaks. You can see the angle incrementing upwards. You can see the fixed height at this time. Now it's going to go to the next height because we're starting the next subrange, and then it will increment downward towards 0 and so on. At the end of this subrange we will do final measurements. It is also possible to do all of the subranges and defer the final measurements until the very end. Some customers prefer it one way, some the other, so we allow for both possibilities. I often make a joke that the great thing about NEXIO is that it's highly configurable, but the problem about NEXIO is that it's highly configurable, meaning there are so many options, so many ways to configure it, and it can seem a little bit daunting at the very beginning, but once again we assist the customer in creating all of the custom templates, validating them, and getting it set up exactly to the way they prefer to do the test. So it's not so daunting after all. This subrange is about to be completed, and then I can demonstrate the scripts that are being used for the final measurements. One thing I can also show in a second are the graph options, which you'll see in the background, a red limit, orange for the measurements, and so on. Here it is going through the steps that I showed earlier for the procedure for the advanced finals. It is going to maximize on all of these peaks. And what I will do now is simply to cancel this, and I will close this in the interest of time, and I will show you a completed test. Here we have a completed test, and I can hit the visualize button to show the data. If I click on that icon, it shows the tabular data up above. I could have also gotten there by choosing the 3 views there, or once again only the graph. Keep in mind I have the ability to look at all suspects, or the ones that were for below and above 1 gigahertz. Same for the final. I can look at all the ones that were found using the quasi-peak detector, those found above 1 gigahertz using peak, and then those found using the average. As I mentioned, we had the graph options. This is for pre-scan measurements. We chose different colors. If we want to look at how we highlighted the peaks, you can choose different symbols, different colors there. Same for the final. And if you notice, we have the ability to control what goes on the screen as well as the printer. Once these are set up according to the preferences of the customer, they can be memorized as default. I will say cancel, and I will simply close this test. We can generate a report. I will click on report, and there are a variety of templates to be chosen. For example, you could choose that template. These are templates that NEXIO creates, and we can do further customization with the customer. I can give it a name, you know, GGG, whatever, and produce a report. Upon doing so, the software will extract information from the individual aspects of the test, graphic data, tabular data, equipment list, and so forth, and it will generate a report such as what you see before you. We didn't fill out all of these details, but it can be noted that the customer can customize these tables, show what items they want to include or not include, and so forth. If I scroll down, we can begin to see the graphic data as well as the tabular data at the very bottom. Useful item is the equipment list, and all of these parameters are also captured. There are instances where a test is done many months later, or for example, equipment manufacturers may want to do what you would call surveillance on products coming in from contract manufacturers, so it's a good idea to rerun tests occasionally, and they want to make sure that all the parameters are correct. If we had test photos, those could have been imported. You know, there's a spot for the company logo and so forth. This concludes the NEXIO presentation. Please be sure to check out our other presentations on other subject matter, as well as a variety of test cases. Thanks for your attention.